Sometimes we illustrate functions using tables, and this is often done if you have a finite set of data, sometimes called also a discrete set of data. And here's an example where you've got the months in the year and the number of days in the months in the month, and the input is the month, and the output is the number of days. So for example, January has 31 days, February 28, March 31, and so on. So if you give me the month, a month in the year, I can give you how many days there are, and I would not give you two different answers. If you ask someone else, it's the same answer. So that makes this table a function where days is a function of the month. So for example, if we call that function f, we could write something like f of January is 31. However, if I give you the number of days there are in a month, you can tell me what month this is, or you could try to guess, but there are many possible answers. So if I tell you there are 31 days in a given month, well, it could be January, could be March, could be May. So the month is not a function of the number of days. So let's first maybe write that down before we move on. So the number of days is a function of the month, but the month is not a function of the number of days. And for instance, January, and I wrote February, but this is false. January and March both have 31 days. Now, having an input that's a word, like January, February, that might be inconvenient. Sometimes we, just like in this case, we could just give numbers to those months, right? First month is January, second month February, and so on. So instead of having January, February, March, and so on, 1, 2, 3, 4, 5 might be more convenient, since we can actually work with just inputs that are numbers and outputs that are also numbers. So in this case, we could write f of 3 is 31 because March has 31 days. So often this is going to be the type of functions we're going to consider. We are going to have functions that map numbers to other numbers, although those numbers could actually be replacements for words or other types of objects. Here's another example where we have different children, children of different age, so 5, 5, 6, 7, 8 here, and their respective height in centimeters. Now try to figure out is if the age is the input and height is the output, is this a table that represents a function? And the answer is no, since 5 is associated with 2 different outputs. So this is not the table that represents a function. So height is not a function of the age of a child in this example. So although tables are useful when we want to illustrate functions that have a finite set of data, we find tables or for finite set of data for phenomena that are actually continuous. So imagine someone recording the temperature outside every time at noon. On every day of the year, you could actually associate to that day a specific temperature. However, the temperature varies continuously throughout the year. So even though the temperature is a continuous function of the time of the day, if we measure it at a precise instant every day, we're actually just picking or choosing precise values of that function at precise instants. So even for continuous phenomena, we could have a discrete set of data depending on how measurements are made.